In this lesson, we're going to talk about parallel lines and the proportional parts. We're going to look at parallel lines in triangles as well as parallel lines that are cut by several parallel lines that are cut by several transversals. Okay, so the first theorem is the triangle proportionality theorem, which says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the side into segments of proportional length. In other words, it's saying that because this line BE is parallel to CD, then it says that AB is eh, the ratio of AB to BC. Okay, the ratio of this AB to BC is proportional, or has a say, or is proportional to AE to ED, and we can use that to figure out the different side lengths. All right. The converse of that says that if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side. So that's saying that if AE, the ratio of AE to EB is proportional to CD to the ratio of CD to DB, then that means that ED has to be a parallel line to AC. All right, so when we do this, okay, we're going to, it says to find the value of x, and we see here that according to these little arrows, RT and VU are parallel. Okay, so we're going to write the ratio of 8 to 3 is equal to 12 to x. All right. Remember, if I do from here to here first, then that means on the top, then from here to here the 12 needs to go up on top and the 3 needs to go on the bottom. I don't have to do it that way. I could have put the 3 up on top and the 8 on the bottom, and then that would have put the x up on top and the 12 on the bottom. All right. So now we just simply have a proportion, and we just cross multiply. All right, cross multiply. 8 times x is 8x is equal to 3 times 12. All right, which means that 8x is equal to 36 divided by 8. And x is equal to, if I take a calculator and divide that out, and I end up with 36 divided by 8 gives me 4.5. All right, so the, this this side length right to here would be 4.5. All right, the next example that I have, once again, we see that AC is parallel to XY, so we're going to go with 4 over 10.5, okay, 4 to 10.5 ratio and a 6 to X ratio. All right, so we're going to do the cross multiply. All right, so 4 times x is 4x is equal to 6 times 10.5. All right, when we do that, 6 times 10.5, we end up with 63. So we end up with 4x is equal to 63 divided by 4 on both sides. 63 divided by 4 is equal to 15.75. So x is equal to 15.75. All right, that's this side length right there. All right, so another theorem that we have, theorem 7.7, is called the triangle midsegment theorem. All right, that says the midsegment of a triangle is parallel to one side of the triangle, and its length is half of the length of that side. Okay, so that's saying that JK is half the length of FJ. All right, JK is half the length of FG. FG. All right, so the midsegment of a triangle is a segment with endpoints that are the midpoints of the two sides of the triangle. Okay, every triangle has three midsegments. Okay, so you have RP is a midsegment between AC and AB. All right, RQ is the midsegment between AC and BC, and PQ is the midsegment between AB and CB. All right, so going on with that, the midsegment of the triangle ABC are RP, which is the midsegment and is parallel to CB. PQ, PQ is the midsegment, obviously, of AB and CB, but it's parallel to AC, and RQ, which is parallel to AB. And this little triangle that's formed here in the middle, but if you draw all three of the midsegments, is called a midsegment triangle. All right, so pause the video and copy these notes into your notebook as well. All right, so the first one says, what's the length of FE? So FE is right here to right here, okay, and it is parallel to side D. All right, side D is 18 units long. All right, we can see that here, but according to the theorem we just learned out, the triangle midsegment theorem, this midsegment, all right, is half of 18, which means that FE is equal to 9. And we know that, and I didn't draw my congruency symbols, but this is congruent to this, and this is congruent to that. Okay, we were given that in the example. All right. Here, also the same thing. Remember, this AF and BF are congruent, and AE and CE are congruent. So it's saying, and then along with that, BD and CD are congruent as well. So AB is this right here, right? This side, and the side that's parallel to that, the midsegment that's parallel to that is ED, all right? So we know that ED is 5, so 5 is half of what? Okay, so AB we know is that the midsegment is half of whatever the length is. So AB has to be equal to 10 because 5 is half of 10. All right? All right. Proportional parts of parallel lines. It says that if 3 or more parallel lines intersect two transversals, then they cut the transversals proportionally. In other words, AB is written as a ratio to BC is proportional to EF, the ratio of EF to FG. All right? So pause the video and copy this into your notes. All right, so in the figure shown below, Larch, Maple, and Nuthatch streets are parallel streets. Find X. All right, so we know that the first proportion is 26 to 13 or 13 to 26. I'm going to write it as 13 to 26 is equal to 16, because we did put the 13 on top, we got to do the 16 on top. 16 to X. Okay, so now when we cross multiply 13 times X and 26 times 16, All right. When we do that, 13 times x is 13x, and 26 times 16, 26 times 16 is equal to 416. Right? Then we divide both sides by 13. All right. 416 divided by 13 is equal to 32. So x is equal to 32. The same thing goes with this one. In the figure down here, it says Davis, Broad, and Main streets are parallel streets, and we're supposed to find the distance between Broad and Main. Okay, so we can say that 8 over 24 is equal to x over 15. All right, when we cross multiply, you end up with 24x is equal to 8 times 15. 8 times 15 is equal to 120. So we have 24x is equal to 120. We divide both sides by 24. 120 divided by 24 is equal to, this cancels out, x is equal to 5. All right? All right, for our last example, we're going to do one that has something other than just numbers and a single variable. We're going to find the values of x and y. All right, so you know here that you notice that here this and this, so MP and QP are congruent. Well, so that simplifies things quite a bit because we know that if they're congruent, that means that the distances or the lengths are equal to each other. So we can just simply say 5y minus 7 is equal to 3y plus 8. And then we just simply solve for y. So we're going to subtract the 3y from both sides, cancels out. We're left with 2y minus 7 is equal to 8. Add 7, and we're left with 2y is equal to 15. We divide it by 2. Y is equal to 15 divided by 2, which is 7.5. All right. Now that we know that, okay, now we can do the other one. And because of the fact that these are congruent to each other, remember, according to the theorem we just learned about, that if it's cut by three or more parallel lines are cut by two transversals, then then it splits it into proportional parts. Okay, so that means that this ratio between this and this, because they're congruent, this is a 1-to-1 ratio. All right, which is just simply saying that this and this are equal to each other. Well, if it's proportional, then that means that this and this, so JK and LK, are also congruent to each other. All right, because this is congruent and because we have parallel lines, that means these distances here are also congruent to each other. So we can just go through the same thing. So 6x minus 5 is equal to 4x plus 3. All right, and we're going to just solve for x. So we're going to subtract 4x minus 4x. 2x minus 5, or 6x minus 4x is 2x minus 5 is equal to 3. Add 5 to both sides. 2x is equal to 8. to get the x by itself, you divide by 2, x is equal to 4. So we know that y is equal to 7.5 and x is equal to 4. All right, so if you have any questions, make sure that you ask me, and we'll talk to y'all later on.